Hello, this is Dr. Mears. Today we are going to be working it out. This is going to be, we're going to be doing some examples on scatter plots. We're going to be drawing our line of best fit, trying to tell what type of correlation there is, and what conclusions we can draw. So you are going to have to do this on all of your activities, your assessments, your formulas, all that good stuff. But this is very important to beginning to be able to analyze data, especially in statistics. This is one of my favorite things to do, is to try to find that linear trend. Even though the points may not be perfectly linear, you might not see a perfect rate of change. So let's go and work it out. So let's break out our trusty rulers here, and we're going to be working on the first one, which is going to be shoe size and height. And this is of a basketball team's shoe size. And so what we're going to do is the first thing, draw a line of best fit. Now, when you draw a line of best fit, what you want to try to do is get as many points above the line that you're going to draw as below. So if I draw this line right here, this looks pretty good. I have 3 lines below, so if I drew a line, I'm actually going to draw it in because I really like this line. Okay, so I draw that line and using my ruler, I see I have 1, 2, 3 points below and 1, 2, 3 points above the line. And it also crosses about 3 points here. And that's what you want to get. You want to try to go through as many points as possible, and you want to try to get as many points below as above. Now, again, Excel, Google spreadsheets, your graphing calculator, they're going to give you the best line of best fit. But just to practice, locating where that line of best fit is, that's why we're doing it by hand. Now, please also notice down here, I'm not starting from this corner. You do not, repeat, do not have to start from the corner. This is absolutely fine. So it does not have to intercept. It would probably intercept somewhere down in the negative y values down here. So where we get negative inches, which doesn't make too much sense to our problem because we're talking about height and you can't have a negative height. Of course, it can't be negatively height. I guess you could decrease in height, which may be negative. Another story for another day. Okay, so we drew our line of best fit. What type of correlation is there? So what we have to do is we start with this x-axis. We start with the shoe size, and we have to look. We're going to be reading the graph from left to right, just like we always have been. So reading it from left to right, we see our shoe size is going to be increasing. What happens to these points? Well, as we read the graph from left to right and our shoe size increases, we see that our points are also increasing, which means our y variable, which is our height, is also increasing because our points are going in the upward direction. So the type of correlation, because the x variable is increasing and the y variable is increasing, we're going to have positive correlation. And correlation meaning they are increasing in a linear trend, and that's why we drew our line, because we're representing this linear trend. Now, what conclusion can you draw from this data? So this is justifying our reasoning for positive correlation, and it's exactly what I stated. As your shoe size increases, and it's not really yours, it's the basketball team's, so let's put that as the basketball team or basketball member shoe size, basketball person's shoe size increases. What happens to the height? The height also increases. And you do not have to erase this, just doesn't look very neat for me to do on camera, so I'm just going to erase this. I'm going to write it a little bit neater so you can see it. So basketball person's shoe size increases, then their height increases. Meaning, if somebody's shoe size is a 14, then they probably are going to be pretty tall. I bet you they're going to be playing forward, huh? Anyways, okay. Or if their shoe size is 12, then they probably would be on the lower end of the height. Bet you it's a guard. All right, well, there's a shout out to March Madness right now. Okay. My team's not in it, so I can't say, hey, I love UConn, but, maybe next year, everybody. All right, let's go to the second one here. The second one are going to be your days absent and your grade, and this is on grades and attendance. So again, we have to draw our line of best fit. So let's take our trusty ruler. Let's try to get through as many points as possible. Now this is pretty tough because we have a lot of points. So I am going to try my best to draw my best fit line, and I'm thinking that's probably it. Maybe over here a little bit. So I'm going to try right here. Let's see how that is. Maybe up a little bit. I don't know if I got through too many points. And again, we're not going to be perfect. We really just want to get through the middle part of the graph, making sure that we're crossing 2 or more points. So when I see that I've crossed like about 1, 2, 3, 4 points, and it looks like there's even the same number of points below down here as there are above. So I don't want you to worry that it's not going to be perfect because, again, we can use our technology to make sure that we get the best fit line. We're just practicing locating our best fit line, which is why we're doing it by hand. Okay, so we drew our line of best fit. Let's look at the correlation. So again, let's start our x-axis. We read it from left to right. So the days absent, we see the days absent are increasing 0 to 25. Let's look at the overall trend of the points. What's happening? Well, we're seeing the overall trend. If we read the graph from left to right, the overall trend is it's decreasing. So the grade is decreasing. So if we're increasing for our x and decreasing for our y, this is going to be a negative correlation, meaning it has a negative linear trend. And I like that. Let's write that somewhere. Negative linear trend. Because that's what negative correlation means. Correlation means that we're looking for that linear trend. Okay. What conclusions can we draw? So starting with your days absent, so we can say the more days absent, and then what happens to your grade? The lower the grade. And if you want to give me a nice example after that, you can say, hey, if you're about 20 days absent, your grade is going to be about a 60. And again, you don't have to be perfect here because we're going to be making an equation and predicting. But just reading the graph, you go to 20, you go up, you see the points are around that 60, 65 range. So that's not good. Stay in school, kids. Okay, and the last one we have here, we see high school grade point average and number of pets. So this is about grades and pets. So drawing a best fit line here. So they're pretty scattered for me. So I'm not sure if I should draw a best fit line this way, if I should draw a best fit line this way. Can I go this way? Can I go this way? What can I do? So this actually, I don't think I can obtain a good best fit line. So I'm going to write no line of best fit, because they are so scattered. So let's even so scattered. This is a true scatter plot. Okay. So what type of correlation? So since there's no visible trend, here we had a nice positive visible trend. Here we have a nice negative visible trend. But because these are so spread out, we have no visible linear trend. So no correlation. And I'm going to also put no visible linear trend. What conclusion can you draw? Well, we cannot draw any number of conclusions here. We don't know. We don't know if the grade point average increases, the number of pets increases. So we can't make any conclusions because we have absolutely no pattern shown. So no conclusion can be drawn on grade point average. Let's put on the relationship. I love that. On the relationship between grade point average and number of pets. So that's great. I like that word relationship because that's what we're looking for. We're looking for a trend. We're looking for a linear relationship. And we can't decide anything here because the points are so scattered. So let's just review really quickly. So first we looked at a positive correlation and we saw that we could draw a line of best fit. And so we said it was a positive correlation because we have, and I'm going to write this in, a positive linear trend. So we have a positive linear trend, which is why we're able to draw our line of best fit. That was a positive correlation. So as shoe size increased, the height increased of members of the basketball team. Here we saw that we had a negative trend, so we drew our line of best fit in, and we could do that because we had a negative linear trend, which means we had negative correlation. And so the conclusion, the justification is that more days absent, the lower your grade is going to be. And lastly, we could not draw a line of best fit because there was so much scatter, which means that there's no correlation, there's no visible linear trend. Can we draw any conclusions? No conclusion can be drawn because we cannot see the relationship between those two variables, grade point average and number of pets. This has been Let's Work It Out, drawing lines of best fit, stating the correlation if there was one, and then justifying our decision upon what type of correlation it was. Hope it helped. Please glue this now into your ISM. Thank you.